Good afternoon, everyone, and welcome to the fourth in our series of A-Level Masterclasses. And this one is exploring the wonders that is A-Level Physics. And I'm delighted this afternoon to be joined by two of our physics teachers. We're joined by Dr. Lucas, who you can see donning that beautiful lab coat there, sir, and then Mr. O'Riordan, who joins us live from his home this afternoon. Thank you for taking the time, both of you, to join us this afternoon, which is great. And I know there'll be lots of students who have told me throughout the day they'll be tuning in and watching this later as well when they can watch this on YouTube to find out a little bit more about physics and pose us those questions. For students that are watching, you'll see in the top corner of the screen, there is a code A667, and that code is a code to use on slido.com, and you can pose questions throughout this session, and Mr. O'Riordan and Dr. Lucas will answer those questions at the very end of this session. And no question is a silly question, so please do feel free throughout the whole of this session to ask questions away. But I guess the first and the most important question, and starting with you, Dr. Lucas, is what is A-Level Physics? Why study physics at Bexleyheath Academy?
Thank you very much. Studying A-Level Physics at BA leads to versatile qualification. You are going to get a fantastic qualification that's well respected by many employers and higher educational sector. Your knowledge becomes increased and you have a better understanding of mathematical application and physics application. Thirdly, it provides you an excellent pathway or a good prep to move into various courses in the university. You develop exceptional employability skills. Why we are so special in BA is that we provide you with 100% support, which is still the best in the borough. We have stimulating and challenging environment to ensure you are successful. And finally, we will guarantee your grades. You come to BA to study physics, your grades will be guaranteed. Typically, most of our students will come up with B's, A's, and A-stars. Those results are guaranteed in as much you do what we've told you to do. Next slide, sir.
Brilliant, thank you, sir. So in terms of, before we go forward, tell us what it is, and we'll start with you, Mr. O'Riordan. Why is it? Because I know that you, dare I say, you're a bit of a physics geek, and you've said that yourself. What is it you love about A-Level Physics?
So I shouldn't ramble too much. So just why I love A-Level Physics in particular is no other course will give you such a broad understanding of the universe and what you see in it, and the explanation of the observations that we can make, and let you make a miniature catapult out of lollipop sticks. You really get that theoretical side and that practical side of science in one subject, which is probably what I enjoy about it the most.
You've got me intrigued there with the catapult, so I must say you pricked my interest. And Dr. Lucas, same question to you. What is it you love about A-Level Physics?
Thank you again. One thing I love about A-Level Physics is that it prepares you for the real world. You become a problem solver. You actually are trained to solve problems. For instance, during these COVID pandemic, physicists are being employed to design the disease sequence and also to analyze the rate at which the disease is spreading. So you are a problem solver always. That's one thing I love about it.
Brilliant. And see, I can see beautifully the slide that takes us further, sir. Where can physics take you in life, I guess, is the question now.
Excellent. Various careers, including mathematician, engineers, data scientists, and so on. So can you move to the next slide where we have detail of where physics can take you to. Mostly into what science careers, including modeling, disease control, disease modeling, quantum physics, astrology, astronomy, forensic science, DNA sequencing, and medicine. Also, if you study physics, you have the best chance of being successful as an engineer. Various fields of engineering, including civil, electrical, mechanical, electronics, petroleum, and so on. Also, other areas include computer, game design, financial sector. Most physicists are now working in financial sectors, cryptography, coding, and telecommunications. Next slide, sir.
So in terms of where, or the course structure now, so that's where it can take us, and a huge range of pathways. And I know a few friends of mine actually studied physics at university and now work in finance, and dare I say, an absolute fortune compared to me. But let's not go there this afternoon. That's a different conversation. In terms of the course structure, Mr. O'Riordan, talk us through. So we know it's an A-level, but what's the assessment look like? What are the modules? Talk us through.
So physics, the end goal of physics is not goal, but the end part of physics is 3 2-hour papers. Each one is weighted the same. So each one is worth 33% of the grade at the end of the second year. Over the course of those 2 years, you study 8 core modules that we will all do, and then 1 of 4 optional ones, which we will go into a little bit more detail in just a couple slides. Over the course of those 2 years, again, you will do 12 required practicals, from everything from looking at waves on string to building circuits and analyzing how electricity works. In terms of the entry requirements to get into this course, though, we do look for a 7 in maths and a 7 in science, because it does build on your understanding of GCSE maths and science. They are very linked in A-level physics. Subjects that go very well with A-level physics include mathematics, chemistry, computer science, geography, engineering, psychology, and biology. Next slide, please, sir. Thank you very much. So, looking at the modules that we would study over the course of the A-level, we would start with measurement and error, where we look at the fundamental units of science that we will use throughout the rest of the course, as well as sprinkling those 12 required practicals throughout the whole course. We would continue to move on to particles and radiation, the next module, that looks at the fundamental particles and energy that makes up everything in the universe. We would press on then into waves, which you would have looked at GCSE, but we build on that understanding that you already come in with and deepen your understanding of the characteristics and properties of waves, how they interact, how they behave. Mechanics and materials comes next, where you would look at the laws that govern the motion of objects, which is mechanics. And then the materials side of this, we go into building on GCSE knowledge of particles and how materials are made up, and how and why we use them, how they behave, the mathematical laws that govern their behavior, and why engineers would decide to use something in particular to build a building. Next slide, please. Thank you. Then the next module is electricity, which does what it says on the tin. You look all into the equations that explain electrical currents, voltage, resistance, how these are built up, how these layer on top of each other, how circuits are created. You would look into the components behind everyday appliances like kettles and toasters. Then we would move on to further mechanics and thermal physics, which would build on our mechanics module from before, taking that deeper yet and looking at more specific motion and behavior of certain systems, such as circular motion and simple harmonic motion. Then we have fields and their consequences, where we would begin and deepen our look into the forces, the fundamental forces of the universe, and how they are really just fields, and how we can look at them together and how they interact with each other, and again layer on top of each other. Then we have nuclear physics, which deepens our look into particles and the nucleus. We would talk about how the properties of those particles, of the nucleus itself, is used in modern science, including nuclear power, how we can use our understanding of the nucleus to generate energy and electricity. And we would look at the properties of unstable nuclei and radiation. Sorry. Next slide, please.
Brilliant. Am I right in saying, sir, that those are all the core units that every student would do? Is that right?
Absolutely. So the 8 modules that I've just discussed are the core modules that we would all do. And then the 4 on the screen at the moment are the optional modules, where we would pick one as a class based on what you as the students are most interested in. So if we had a lot of aspiring engineers, we would pick the engineering physics module, where we would look into thermodynamics and how pressure and volume relate to one another. If we had a lot of aspiring astronomers joining our physics A-level course, we would look into the Big Bang Theory and how stars are born and how they die. In that case, we would pick the astrophysics module. Then we also have the medical physics module, which is where we learn all about how every machine you've ever seen inside of a hospital works, the physics behind them. And then there's the electronics module as well, where we take a deeper dive into the building up of electronics and how they work, the parts that go into them, how they work with one another to build up the complicated and electrical world that we live in. And that brings me to the end of our look at the modules that we would study.
Brilliant. Thank you, sir. Really interesting. And I must say that astrophysics one has definitely grasped my attention. That's the one I'd want to do if I was in your classroom next year. Brilliant. Thank you very much. Really interesting course overview. And I can see already, and I'm going to go to the next slide, because we've been having questions come throughout the presentations, and some of these might have already been answered. I know that you answered the what goes well with A-level physics earlier on in the presentation. A couple of questions here just to throw at either one of you. The first one there, do I need to be good at maths to study A-level physics? Now, I know that you mentioned the entry requirement, Mr. Arida, number 7. How important is maths, I guess, for an A-level physics student? And maybe over to you, Mr. Arida, first of all on that one.
Maths is important, not to sugarcoat it, but in physics in particular, it is the science, the A-level science, that does require quite a lot of maths. I think we came to say about 60% of physics is looking at equations and manipulating them and working with them to explain the universe about us. So it is important, but it is something that we would support you with and work with you with to improve.
Brilliant. Thank you, sir. And I can answer the next question now. It says, do you also offer chemistry? We do. Really pleased to say that actually all 3 sciences and A-level maths are all available here at Bexleyheath Academy, which is great. So absolutely, if you're interested in the sciences, this is the place to be. And we've deliberately, of course, put those sciences in different option blocks so you can study all 3 and maths if you so wish. I can also answer the next one. I shouldn't answer them for you, sir, but given the questions there, how many lessons are there each week? But Dr. Lucas will want to jump in here, no doubt. So there are 4 lessons a week, and it's split between our 2 teachers. But Dr. Lucas, I know you do a lot of interventions. Do you want to talk us through a typical week for a physicist here?
Yes, as we said, we guarantee our students' grades, and we actually support them, providing intervention both in the mornings, 8 o'clock, and also after school. So we have 2 mornings and 1 long afternoon to ensure we are ahead of the task.
Brilliant. Thank you, sir. And I saw a question there from Lisanne, and I ticked it thinking I was liking it, but I've ticked it off the screen. But fortunately, I remember it, Lisanne. So apologies for that. And Lisanne asked us, how many groups will there be for physics next year? And would they therefore get to study different options? And Lisanne, there will be as many groups as we need in order to cater for our students. But sir, you mentioned the options. How do you go about deciding those options in a class? Mr. Arida, perhaps to you first on that one.
Yeah, so we would decide the options based on what the class as a whole would like to study. But with the time requirements, you would probably only get the opportunity to study one of those optional modules as a class. So you wouldn't likely get the option to study more than one of those because they take up several weeks each, and you only need to do one to complete the A-level requirements.
Well, as I said, astrophysics has my vote, but I probably won't be in the class next year, dare I say. And I can see a question here. I know I've been certainly asked this in the corridor, or maybe Dr. Lucas for this one. Someone said, do we need physics to get into medicine? I think I know the answer, but Dr. Lucas, maybe you should clarify on that for us.
The answer is no, you don't need physics, but it's a very good subject to study if you want to go in for medicine, because it gives you problem-solving skills. Also, it's not a compulsory subject you have to study, but it's a good thing if you study physics.
Brilliant. Highly recommended, isn't it? I think is the general consensus. Brilliant. That brings us to the end, and I haven't seen any more questions come through, which must mean that your presentation has answered all the questions as we've gone through. Thank you, gentlemen, so much for your time this afternoon. It's been an absolute pleasure hearing about the subject, and especially about those optional modules that I must say look very, very interesting. I know we've had a lot of interest in A-level physics already this year, and looking forward to a healthy cohort of physics students next year coming through the academy. As always, the message is the same for those of you watching either live or if you're watching this as a recording. If you have any questions at all, please don't hesitate to reach out to myself, and my email address is jsparks@bexleyheathacademy.org, or Mrs. Presney, who's the head of Sixth Form, lpresney@bexleyheathacademy.org. And if we can't answer, we'll pass the questions on to Dr. Lucas and Mr. Reardon. Thank you, gentlemen, both once again for your time this afternoon, and thank you for those of you watching either live or watching this on our YouTube later on. Bye for now, everyone.